Hi everyone, this video is going to cover in Algebra 2, it's section 9.2, and it's arithmetic series. I keep wanting to say sequence. So we already covered the series. Now let's look at what we already covered a sequence. Let's look at what the series is and talk about that a little bit. A series is the sum of all those terms in a sequence. So it's the sum, remember sum means adding them up, of the terms of a sequence. So the sum of the terms of a sequence. So we're adding up all those terms. Well, we have to stop the terms, right? So they have to have an ending spot in order for us to add them up. We can't be going on forever unless it is like converging to a specific number. Then we can say it converges to this number. So we're going to kind of look at that idea. So let's look at the first word here is finite. So a finite series is where it actually stops, right? It has a first and a last term. Is how the book defines it. So you have a first term and a last term. It stops. So a sequence that maybe goes 2, 4, 6, 8, 10. Done. That's finite. If it's infinite, it's going to continue without an end. And we've seen this in sequences. And so infinite is it keeps going and going and going and going. So we'll look at those. So when we look at the sum of a finite series, we have an equation for it. So the sum is S in terms of n. And I'll define these letters for us. N divided by 2, and then it's going to be A1 plus A to the N. So what are all of these letters? Sorry, my nose is running today. A1 is always our first term. A to the N is that nth term. N is the number of terms. So N is the number of terms. And sometimes we have to figure that out. Well, what is the number of terms? And A1 is our first term. And we've seen that before in our other sequences formulas. A to the N is our nth term. Typically our last term in a lot of the sequences. So we have this formula that's going to tell us the sum of a sequence. So we haven't really got to what a series looks like quite yet. Getting there. Let's look at a sequence and let's find the sum or the series of it. What if I just went 2 plus 4 plus 6? So this is the sum. So it's a series, because I'm adding them up and I say, okay, the pattern starts with 2 and it goes 2, 4, 6, blah, 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 blah to 100. So we have our first term, our nth term, or our last term here, and they're adding. So that's the difference. There's not a comma. That's going to make it a sequence. Series, now we're adding. So we're going to use this formula. We're going to know S to the, well, how many terms do I have here? Well, from 2 to 100, this is our first term. One way to find out how many terms you have, which we need to know, is what are we going up by each time, that common difference? And we're going to take the 100 and divide by that common difference, and that would give me 50, right? Because 100 divided by 2, this is just going up by 2's, is 50. Okay, so S to the 50 is how many terms we have. So how many terms you have can be the tricky one. And I'll look at one that's a little different and I'll show you. Because one thing we can do, and it works every time, is we take the 100, the last term, minus the first term. So I would take 100 and I'd subtract 2, which gives me 98. and I divide by what we're going up by, the common difference, which is 2, and then you add one more term to it. Okay, so a little tricky. I'm subtracting off these two, and then I divide it by what you're going up by, which is 2, and then I get 49 there, right? So 100 minus 2 is 98, divided by 2 is 49, and then I have to add one more term to get to 50. Sounds a little bit tricky, but we're saying, well, okay, so if I would have started way up more, I still need to know how many I subtract off to get to that first term, and then I'm subtracting that off that last term and then dividing by how many sets I'm going to have, or how many numbers it goes up by each time. And we'll look at it again and again, so maybe it'll make a little more sense in a second. But so we know our n is 50, so we're going to have 50 over 2. Our a1 is 2, and our an is 100. And this is our formula. So this is going to be 25. So s, the sum to the 50, is going to equal 25 times 102, which is 2,550. Okay, so the sum of this specific sequence here happens to be 2,550. So let's look at another one. All right, so what if I go 4 plus 9 plus 14 plus 19, yada, 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 all the way to 99. Okay, these are arithmetic, so they better be going up by the same common difference each time. So what are these going up by each time? So 4 plus 5 gets me here. 9 plus 5, 5, 5. So it's going up by 5 each time. So my common difference is equal to 5. Okay, so that we have to look at that. What are we going up by? Now, what is our first term? What does that equal? Well, like I said, 99, we're going up by 5s. You can't divide 99 and 5 into 99, so it's a little tricky on that. So what I'm going to do is I'm going to say, okay, there's 99, and I'm going to minus the first number of 4. That gives me 95. It'll always be divisible by your common difference, which is 5, which gives us 19 terms from this number on. Well, we have to include this as our first term, so there are 20 terms. Oops, I called this A1. That's right. A1 is 4. So our N is 20. There's 20 terms. Okay, and then our A to the N is going to equal 99. So again, I took 99 minus 4, divided it by 5, and then added 1 to get to my 20 terms. Now I can put this in the sum to find the sum. So I'd have the sum of the 20 terms is equal to 20 divided by 2 times 4 plus 99. That's going to equal 10 here, right? Times 103, which equals 1,130. So there's the sum, or the series, of that sequence. Okay, so that's looking at them set up this way. Here's another way you might see them. You might just be told, okay, A1 is 10, the D is 2, find A to the 50. And then find S to the 50. Oops. I did not look at an S. I wrote a 5. Okay, so what am I looking for here? I want to find the 50th term. Then I want to find the what the sequence adds up to all the way to that 50th term. What does all those numbers add up to? So what did they give me? They gave me the first number, and they gave me the common difference. Remember, that's called D or they let it be D when they taught us the formula for sequences. So let's look at the formula from the last chapter for the explicit explicit sequence. The formula said a to the n is equal to a1 plus n minus 1 times d. Oh, whoop, whoop, whoop. It's hard to, when I get to the bottom of my paper. All right, maybe I'll just let that fall. Okay, so there we are. There's our formula that we learned in the last section. So we want to find the 50th term. So we would say A1, which is 10, plus n, how many terms is 50, right? Because we're going to the 50th term. Minus 1 times d. Well, d is 2. That's our common difference. And then we just simplify this. All right, 50 minus 1 is 49. 49 times 2, make sure you times first. And then add the 10 is 108. All right, so now that we know that last term, then we can find that series or that adding it up. So you have to understand that you're going to, or not understand, but you have to remember the explicit formula for an arithmetic sequence in order to find that last term on quite a few of the questions that you're asked on your homework. Not quite a few, but on some of them. So then now we can find our s to the 50, and we're going to have, okay, we had 50 terms. So we would do 50 divided by 2. And then 10's our first term, plus 108 that we found for our last term. And that's actually going to give us 2,950 when I add it and multiply it out. So add and then multiply. So I could be asked to find a term again in order to be able to use it to find our sequence. Now let's look at how a lot of these series, what they're added up to. Let's look at how these are usually written. We have this kind of funky Greek letter that we use. It looks like an E, but not quite, and it means sum. This is the summation, okay? So that means add things up. So this is what we use a lot in a series, is this symbol. And let me label some things on here. So we're going to have n equals, maybe, it doesn't matter, just any number here. And then up here, I'm going to have another number. And what this part is our lower limit, or what you start with. So this is they just call it our lower limit. Or our starting number. And then this is our upper limit. So for example, like on a, you might go from 1 to 5. I want to count from term n is equal to terms, right? Term 1 to 5. Okay? And then what we put after, which I didn't really leave myself room, so maybe I'll put the little x here. Okay? So this x here means is the explicit formula for it. Found here. So what this is telling you is, okay, start with this one, this term, go to this term, here's your formula. And add them all up, because this means sum. And that's kind of where it goes. If you happen to have an upper limit of infinity, that's an infinite sum. So your series is going on forever. In this first section, you don't have infinite. You have all, no, they're all finite. So let's look at this written on a problem. We would say something like 1 to 5 to n minus 1. Okay, here's a series. What are we doing? What is this telling us? Well, it's saying add them up, start with term 1, go to term 5, there's your formula. So here's the kind of long way to do it that we can easily do each time, but what we would do is we would say, okay, for n equals 1, put that in, I would have 2 times 1 minus 1, which 2 times 1 is 2, minus 1 is 1, and then I could say, okay, now n equals 2, going from 1 to 5 here, I'm going to go up to 5, so I'd have 2 times, now 2 minus 1, that's our formula, 2 times 2 is 4, minus 1 is 3, So then I go in equals 3. Okay, so 2 times 3 minus 1, 6 minus 1 is 5. And into equals 4. 2 times 4 minus 1, 2 times 4 is 8. 8 minus 1 is 7. Into the 5. And that's as high as we have to go, is into the 5. 2 times 5 minus 1 is equal to 10 minus 1, which is 9. So I did, and I found the sequence that goes with this series. It's a sequence that goes 1, 3, 5, 7, 9, and I wanted to go from 1 to 5, and I want to add them up. So then I could just add these up. 1 plus 3 plus 5 plus 7 plus 9 is going to give me 25. Did I do it right? 4, 9, 9 and 9 is 18, 19, 20, yep, 25. So this equals 25. That's my answer. Great. Not that bad. You put in all, you're finding the different sequence and then you add them up. Well, what if it went from 1 to 220? I don't want to add those up, right? That's way too many numbers. So we can use the formula, and what we would do for the formula is we would just find the first term, which we already found is 1, and we would find the last term, whichever goes with the top number, which we already found is 9, and we would use those with our formula, okay? But what am I going up by? So let's look at this. We'd say, all right, now we know this is only going to the 5th for the sum, and we know that we have 5 divided by 2. So 5 is, right? Yeah, it's just n. Okay, yeah. And then A1 is 1 plus 9. And this is 5 divided by 2 is 2.5. 2.5 times 10 is 25. So I get the same answer with this way or this way, right? But this way is not reliable. I cannot add them up all the time. So this is what we would look for. First term, last term, use them on the formula. Okay, let's do another problem. Okay, so my second one with using the summations. What if I say I'm going from n equals 5 to 10 for 20 minus n? All right, oops, there's our problem. We go from 5 to 10, and our formula is 20 minus n. Well, what's our first term? So what is n equals 5, or a to the 5? You would put the 5 in, so you'd have 20 minus 5, which would give us 15. Then put in the 10, so you're kind of doing the 10th term here. So 20 minus 10 is equal to 10, and then you use your formula of s to the, well, here's where it's a little tricky. How many terms do I have if I go from 5 to 10? I have 5, 6, 7, 8, 9, 10. So I have 5 terms. But I have 6 terms. I thought I had 6 terms. Oh no, we just still use s to the 10. No, then they want just the 6. Sorry, confused me for a second. So we don't have 10 terms here. Hang on just a second. Okay, so where do we get, so I was like, wait, did I do something wrong? So just pause the video for a second. Where do I get 6 terms? Well, think about it. You're starting with 5 and you're going to 10, right? 5, 6, 7, 8, 9, 10. But each one is a term. 1, 2, 3, 4, 5, 6. So it's like I have to go 10, and I have to add that one. 10 minus 5 is 5 terms, but I have to add one because it's like that original one does count, or that first one does count. So there are 6 terms, which is a little bit tricky. And so we have 6 terms, so we'd have 6 divided by 2, and then we'd have that 15 plus the 10. So we end up with 3 times 25, or 75. All right, so figuring out the number of terms again. First, last, you can subtract them, divide by the number that you're going up by, which can be tricky on this. We're going up by ones because it's a 1 is our slope in front of n, or our rate. So we could still do it that way. We could go, okay, 10 minus 5 for the terms is 5. And then divide it by the number in front of n, which is 1. So 5 divided by 1 is 5. So there's 5 terms, and then I have to add 1 at the end to get the 6. So a little bit tricky, but that's how we do it. Okay. Let's see. I thought there was one more I wanted to make sure I showed you. All right, what if I have, this is my third one with the symbol, what if I just have a to the 1 is 4, and I know s to the 40 is 6,080. What is the nth term? What number, or what did I go up to? So here's what I'm given. A to the 1, right, is our first term is 4. Our 40th term is 6,080. What was that nth term? Well, from here, what we're going to do is we're going to use that formula. We don't know the nth term, so we'd say s to the n, this is what we're looking for, is equal to we don't know over 2. And then we know 4 is our first term plus, I don't know, here. So here's where we're at. Well, we could figure out how many terms we're going to go to. Oh, so that would be 40, right? So we can fill in n, but we still don't know a to the n, because we can fill in the 40 from here. We had 40 terms, so we can simplify this a little bit better and have, so we're still looking for s to the n, oops, s to the 40. So we now know n. Well, we knew it from the beginning, but I didn't write it down. So here we are. So we have now that 40, we know it's 40 terms, and we can simplify this even more. We know s to the 40 is 6080. So 6080 equals 40 over 2, 4 plus a to the n. Then I can simplify this. Let's see, 40 over 2 is 20, right? And this is being times by this, so I could distribute it, but then I would have to divide it out twice. Kind of a silly step. So I can divide both sides by 20. That's going to cancel these because that 40 divided by 2 really is 20. And 6080 divided by 20 is 304, which equals 4 plus a to the n. And then subtract the 4 and you get 300. Is a to the n. So we can find missing a to the n's by using the formula and putting in what we know. Well, we knew s to the 40 is equal to this, so I could use that knowledge of that the 40th term is 6080 and go from there on solving. So you kind of work backward. So we're working with adding up things. So some of them you're going to see with your symbol, right? Starting point, ending point. If they're small, you can do the long way. Otherwise, use the formula. Find the first term, the last term, and then use your formula. If it's in this form, it could be also, right, in form where it's plus plus plus, the series is already written out kind of for you. So then again, that one's a little easier and you could do your formula from there. Or you could be missing a term and have to use your formula to find it. All right, let me know if you need help with this section.